Welcome to the lesson, What is Conservation of Mass? In this lesson, you'll explore the relationship between the mass of a whole object and the sum of the masses of its parts. Matter is anything that has mass and takes up space. Which has a greater mass, a kilogram of feathers or a kilogram of steel? Type your answer in the box, then click OK. To test your answer, drag the feathers and the steel to the opposite side of the scale to see what happens. It looks like a kilogram of feathers and a kilogram of steel have the same mass. Mass is the amount of matter in an object or substance. Two masses can be compared by using a balance. You have two objects of identical size, a wood block and a metal block. Which has a greater mass? Place the items on the balance, click the correct answer, then click OK. Right. The metal block has more mass than the wood block. Let's see if we can guess how many apples are in the paper bag. We can do this by adding apples to the other side of the balance until the balance is level. Click the Add Apple button to place apples on the balance. It takes 3 apples to balance the contents of the paper bag. Mass can be measured in grams or kilograms by using a balance. Scientists often use standard masses to determine the mass of an object. Greengrocers use masses to weigh fruit and vegetables. Here's what you'll use to perform your experiment. A balance. Different objects to measure: spring, ice cubes in glass, toy car, clay vase. Standard masses of 10 grams and 100 grams. You will be able to use the table to record the masses of the objects. Now, give your plan a try. Find the mass of the objects on the balance by dragging them onto the pan. Then, use the standard masses to balance the pan. Don't forget to record the mass in the table. When the table is complete, move to the next screen, where we can find the mass of each object after it's been broken by our wrecking ball. Place the standard masses in the other pan of the balance until the balance is equal on both sides. Record the mass of the spring in the table. Repeat this process for all the objects. Okay, Let's release the wrecking ball on some of our objects to see if changing an object's form changes its mass. So, now that the ice has melted, the spring has been stretched, and the car and vase have been broken into pieces. Let's measure the mass of each of them again and compare our results. What happened to the mass of the objects? Analyze your results. Record your answer in the box, then click OK. Here's how scientists explain this. The mass of an object does not change due to a change in its size or shape or state of matter. The mass of a whole object is always the same as the sum of the masses of its parts. This is a fundamental law of nature, the law of conservation of mass. What can you conclude about the mass of an object when it changes size or shape or state of matter? Record your answer in the box, then click OK. Which of the following statements is correct? Click your answer, then click OK. Container A has a mass equal to the mass of container B. Right. The two containers are balanced. Therefore, their masses are equal. One of these cardboard boxes is about twice as large as the other, but you don't know what each one contains. What can you tell about the total masses of these two cardboard boxes, including their contents? Click the correct answer. Nothing, because the box sizes tell about their volume. Right. The volume of a box does not indicate the mass of what is inside the box. You've learned a lot about what is conservation of mass. Before we finish, let's take a quick look at the main points you covered. Mass is the amount of matter in an object or substance. You can compare two masses by using a balance. However you change the shape or size of an object, the total mass of its parts stays the same. The mass of an object is always the same as the sum of the masses of its parts. This is called the law of conservation of mass.